All right, welcome back to class, everybody. This is our first video for the online basic stats course that we are going to continue on. We have just a few chapters to cover. First, I'm going to finish chapter 5. We went over the PowerPoint and pretty much finished the PowerPoint in class. So if you don't have the notes, contact anyone else in class and see if you can get the notes from them. I will be posting the PowerPoint. In fact, I can go ahead and see if I can post that PowerPoint. So material, topic, create topic, chapter 5, add, going to add file, which is the chapter 5 PowerPoint, upload, chapter 5 PowerPoint, post. And there it is, chapter 5 PowerPoint. So feel free to look through it. It was pretty helpful, but to be honest, right now we're going to do some example problems on Google Sheets, if we even need Google Sheets. If not, we are going to use just kind of a Blackboard. Don't want to be over there. Yeah, so we'll use this. I'm playing around with this setup. Hey, we can have a white color. So the first question, again, I'm just playing around. I got some new tools to do all this stuff with, and I'm kind of playing with it. So first question on page 109. So we are on page. Oh, got to do this. All right. Okay. Oh, that's right. I gotta go to pen mode. Ha ha ha. Messing around now. All right. So. That. So this is right. Maybe a little bit. Oh. All right. I don't know what's keeping this up. So let's try just a regular old whiteboard, and we'll use just regular black ink then. So, working fine earlier. Don't know what's going on. All right. Something's up. Fine. That's working fine. What's going on with you? There we go. Page. All right, let me see what's up here. All right, so page 109. That'll working now. Yeah, this is gonna be fun messing with this. All right, this says verifier claims. Example 5.2 gives the equation of the regression line of new birds, y, and the percent of returning birds, x, for the data in the exercise 4.4 has. So let me see if I can find that, because I have downloaded. Let me open that file. So we can just have the book out. Look at the book, what the book is saying. Go ahead, this was... There we go, scatter plots and correlation. This is chapter 4. I need chapter 5. There it is. Hopefully there's more pages of these, otherwise... going to be real fun. We're on page 109. Right here. So it says verify claims. Given example 5.2 gives us this equation. Use your calculator's regression function to find the equation of the least square regression line for the data from exercise 4.4. in your calculator. All right. Okay. So that's the equation they gave us. Okay. Basically, we want to verify this by using our own method of doing that. So to do that, I will need to go to Google Sheets I have open. And I'm going to need to put the data in from 4.4. Now that's from chapter 4, section 4. Or sorry, chapter 4, table 4.4. Question 4.4. All right. Let's see here. Here it is. Yeah, 4.4, question 4.4. This was on page 83. Let's see if I can just type in 83. 83. Not quite. A little off. So here's the data. I'm going to put this in Excel or Google Sheets, not Excel. Zoom in a bit so I can see it. So percent returning, so percent returning. And we have new adults. The percent returning 74, 66, 81, 52, 73, 62, 52, 45, 62, 46, 60, 46, and 38. And then new adults 5, 6, 6, 8, 11, 12, 15, 16, 17, 18, 18, 19, 20, and 20. So we're going to open this up. Now I want to find the equation. The way we're going to find it is we are going to select my columns, insert chart, and where'd it go? So insert, there it is. Okay, insert chart. And we are going to customize. Let me see here. I think it's series. And trend line is what I want. And on the trend line, we want to, where is it? Label, no, somewhere on here. Somewhere on here. Legend. What? Okay, share squared. Somewhere on here it says show the equation, so I remember where. Oh, we did this in class. Use equation, there it is. Okay. Label, use equation. So there it is, there's the equation. So is this the same equation? Now I'm going to say Google Sheets does tend to round a bit here where our book doesn't round. So this was back on page 109, which I think is 101. off by like 2 pages. So negative 3.04, yeah, that's good. And then 31.9, again, it tends to round. I don't know of a way to fix the rounding issue. So I'm not going to stress it too much whenever, if ever we do a tester quiz. I will have to figure out how to do that as well. So there we go. There's how we create our equation. All right. Now 5.2, a study of king penguins looked for a relationship between how deep the penguins dive to seek food and how long they stay underwater. For all but the shallowest dives, there's a linear relationship that is different for different penguins. The study report gives a scatter plot for one penguin titled The Relationship of Dive Duration dd to Depth d. The duration dd is measured in minutes and depth d is measured in meters. The report says the regression equation for this bird is the dive duration is equal to 2.69 plus 0.0138 for depth. Right, so that's per what, meters of depth. So what is the slope of the regression line? Explain in specific language what that slope says about the penguin's dive. I don't need this, so I'm going to just write it over here. I'm going to clear that. All right, so part A, let's see if I can write now. All right, part A, over here. Slope. Now, slope is always the part without the variable. There's our slope. Okay, so slope with the variable. So since this is our variable d, that is our slope. Our slope is equal to 0.0138. And you have to excuse, this is not as easy as it looks to write on here. So now, what does slope mean? All right, what it says is, what it means is for every unit change, now in this case units would be meters, so every 1 meter change in depth the average change, you have to use that word average change in dive duration is 0.0138, and it's in what, minutes? So again, terrible handwriting, but I'm writing on a blank tablet right now. It's the only thing I have to write on. I have another tablet I may choose to change to, but I'm trying to do this on a computer where I can save my videos a little better. The difference is I'm going to have just awful handwriting, even worse than normal. So maybe I'll get used to it one day and be a little bit quicker at it. But until then, you'll just have to listen and follow along as best as possible. So anyway, all right, so that's part A. Part B, according to the regression line, how long does a typical dive to a depth of 200 meters last? Now, what that means is they want us to plug in, where's my pen at? They want us to plug this in for D. Okay, so I'm going to put that over here. So part B, got plenty of room here. They want us to put y hat, because that's our prediction, is equal to 2.69 plus 0.0138 times 200. I'm sorry, thought I had more room. Could have moved it over. I don't think I can anymore. So anyway, they want us to plug this in, and I'm just going to use a calculator for this because I'm just plugging the whole thing in a calculator. So I have a calculator right here. All right. That's still showing up. So we're going to plug in 2.69 times 0.0138. Oops, let me clear this. That is 2.69 plus 0.0138 times 200. So, what this says is if you want to change this to minutes and seconds, you can. But the average time, I'm not in pen anymore, so pen. So the average time, y hat, the predicted time, is 5 minutes and 45.45 seconds. So that's a little bit less than half. So 0.45 times 60 would be 25 plus 28 seconds. 5 minutes, 28 seconds. Okay. Or you can just say 5.45 minutes. I'm not going to be that picky on you. Okay. I'm not going to convert to seconds. I mean, I'd be impressed if you did. Okay. Not that hard, but yeah, not a big deal. Now, the dies varied from 40 meters to 300 meters in plot. Plot the regression line from 40. I'm not going to do that because I don't have the data. There's no point in plotting a regression line without the data. This basically wants you to show that the regression line starts at 40 to 300, and really it just means that you need so parts, and that's just awful. Let me erase that. All right. So C, part C, what they want you to do is basically do just do two ordered pairs, 40, plug it in, and then do 300. Plug it in, find your two ordered pairs, and just draw the line, because that's the regression line. And when I say draw the line, it's actually going to be a line segment, because it's going to start at 40 and then end at 300, because you don't want to go any further than what the data says. So basically that's all they want you to do. I'm not going to have you do that because that's just a bit of a waste of time. Okay, we've actually have visual representation of the regression line as we do this, so there's no point in doing this. Come on. There we go, that's what I'm looking for. All right. All right. So sports car gas mileage, and table 1.2, page 12 gives us city and highway miles. A scatter plot shows a strong positive linear relationship. Find the least square regression line for predicting the highway miles. So I'm going to have to go back to page 12. Okay. And then answer the questions. So I'm going to have to make the scatter plot. Go back to page 12, which I think everything's off by 2, so maybe page 13. Almost. There it is. So, nope, it's not city and highway miles. Page 14 it is then. There it is. So, I'm going to go to, not Excel, I'm going to go to Google Classroom. Zoom out a bit here, because that's a bit nuts. There we go. delete that. I don't need this anymore. Doing city and highway miles. This is city and highway. So it gives you, let's see if we can see everything. Yeah, we can. So it gives you 17, 20, 22, 14, 19, 20, 13, 18, 18, 11, 17, 57, 29, 22, 16, 13, 23, 20, 15, 19, and 25. How are we doing here? 19, 15, 20, 23, 13, 16, 22, 9, 20, 57, 17, 11, 18, 18, 13, 20, 19, 17, 22, 20, 17. Okay. Highway 24, 28, 31, 25, 27, twice, 21, 25, 23, 16, 23, 56, 26, 13, 28, 23, 19, 30, 26, 22, 27, and 30. All right. So we should be good on those. Now it says it shows the scatter plot shows a strong correlation, so let's go ahead and do the scatter plot. Insert chart. All right, and there it is. I'm gonna customize this horizontal axis. I'm gonna minimize it anyway. So minimum value seems to be about what? Let's say 28, or maximize the value. There we go. And then, nope, I'm not missing a value because I'm missing one, which is 57. So I'm going to have to go to 60. There's that one right there. So yeah, we probably definitely call this one an outlier. And I think this is a Honda Insight, so definitely an outlier. But let's go ahead and customize this series when adding a trend line. And we're going to label it with an equation and show R squared. So what this tells us, we can zoom in a bit. Not that much. I can't really make that any bigger. I wish I could, but anyway. Okay. So there's our equation. Now, what do they want to know? Back on page 111. Find the least square regression line, and there it is. Make a scatter plot, plot the regression line. Good, we're done there. So part B says, what is the slope of the regression line? Explain in words what slope says about gas mileage of the two-seater cars. So, other two-seater cars rated 20 miles per gallon. The city predict. Okay, so they want us to do those two things. So I'm going to close that. So, let's get right in. Let's go with purple. I like purple. All right. So right here is my slope. So my equation for part A. So if you want to do, and that's really off. What did that do that for? That. All right. The equation for part A is that y hat y hat, I gotta do this slowly, is equal to, again, to put it in order, 9.21 times 0.85, not times, plus 0.855x. Now this is your slope. This right here is the slope. And again, that's the slope. So part B, that's your slope. What does it mean? So B, for each, again, unit change in city miles, so that's miles per gallon change in city miles, the average, again, you have to use that average, spelled all with the letters, average change in highway miles is 0.855 miles per gallon. Right? And then for part C, we'll do it over here so we can see everything. So part C, they want us to plug in 20 miles into the equation. So y hat is equal to 9.21 plus 0.855 times 20. All right, so I'm gonna plug that in the calculator. 9.21 plus 0.855 times 20. 26.31. So the expected average highway miles, okay, expected average highway miles is, where is it? That is equal to 26.31. There we go. So there it is. That's why I scrolled. Okay. All right. Okay, so question 5.4, growing corn in exercise 4.25, page 99, gives data from an agricultural experiment. Purpose is to see how the yield of corn changes as we change the planting rate, so plants per acre. Make a scatter plot of the data, use a scale of yields from 100 to 200 bushels per acre, find the least square regression line for predicting yield from planting rate, and add this line to your plot. Why should you not use regression for predicting this setting? So we're going to go to page 99, so 101. Here it is. Now this one's kind of interesting. Here. Delete. Okay. Leave that there. So we have nematodes and seedling growth. All right, so I think this is the question they were referring to. Let me go back. That was 114, 425. All right. Nope, here it is. Okay, so 425. There's the question. So it's plants per acre. So plants per acre. And yields. Now it said to use everything as 100 to 200. Okay, so use a scale of yields from 100 to 200 bushels. So, so the pattern will be clear. So I think it means, let me think about this for a second. All right, so what this means is to use a scale is we're going to change our vertical axis on once we have the chart up. So let's go ahead and put the chart up. Now here's the thing is we have 3 or 5 values for 12,000. So I'm just going to type in 12,000 5 times. Right. And it had yields of 150.1, 113, and 18.4, and 142.6. All right. I may need to delete this. Let's delete that, and we'll just do another chart. Oh, there's only 4 of them. Okay, not 5. For these, so we had 166.9, 120.7, 135.2, 149.8. And 20,000, 3 of these. And then 24,000. Oh wait, there was 4 of these. 3 24,000s and 2 28,000s. So 20,000 was 165.3, 130.1, 139.6, and 149.9. 24,000 was 134.7, 138.4, 156.1, and then 28,000, 119.0, and 150.5. So let's enter the chart. Insert chart. Now here's the question. The question was, going back here, 114. Once we make this scatter plot, and we find we can add the least square regression line. So customize, series, trend line, and equation, and we can even do R squared. Okay. Here's the thing. This is a curve. Okay, and this is why they want us to do this. We wanted to customize the scale. They want us to use the scale from 100 to 200. So we're going to do vertical axis, minimize 100, maximize 200. Okay, so we can kind of obviously see that there is a curved pattern here. Okay, so what is R squared? R squared is 0.018, which is really tiny. That means about 2%. You want to change the percent, so 1.8%. What does this value say about the excessive regression in predicting yield? It says that this model would be about 2% accurate. Okay, it explains about 2% of the change in yield, or that plants per acre explains about 2% of the change in yield. So not very good. So even regression lines that make no practical sense obey facts 1 to 4. Use the equation of the regression line you found in A to show that when X is the mean planting rate, the predicted Y hat is the mean observation. So here, what they want you to do is to first find the average of the plants per acre and the average of the yields. So here we go. Plants per acre average with an R, and then yields average. So we're going to set the formula equals average of this column, all right, and equals average of this column, okay, equals average this column. So what's this saying is if I plug in 18823, okay, 0.5, we'll go 0.53. All right, so I take this equation, which is really hard to read. So let's write this equation down. I'll put it over here. So it says y is equal to, now that is 0.402 to the negative times 10 to the negative 4th power. That's scientific notation. That's how small that is. So let's do 132 plus 0.000402 times x. And that is your equation. Okay, so I'm zoomed in so we can see the whole thing. So yeah, this is really small. Okay, so they want us to plug in this in for x, see if we get that for y. So I'm going to do that here. Okay, so equals 132 plus 0.000402 times 18823.53. All right, apparently I have to just type in the whole thing. 52941. Well, there's some rounding there, so yeah, where I would definitely like to have Excel. Let me see if I can do this in Excel, which, by the way, you'll be glad to hear. I was just updated today that Microsoft Office is now on all the computers at GCA. And as soon as I heard that, I'm like, well, that doesn't do anybody any good. Thanks. So, but hey, if we ever get back there, we can use Excel from that point on. All right. But the whole idea, and it is pretty close, the values are pretty close. If I plug in this number, I get a number close to this one. And if I rounded it, it would be 140. Okay. So, yeah, there it is. That's all they want to do on that one. All right, let's see here. 5.5. So we did that one. Oh, they just wanted you to do the same thing. Plug in the mean for the city and highway miles back to that equation we had earlier to see if you get the same. The point is, if I take the mean of my x value and plug it into the equation, I should get the mean of the y value. The equation, the linear regression equation, always crosses through the mean of the x and the mean of y as an ordered pair. Okay, so I'm gonna move on. Residuals, I'm not gonna really concern myself too much with residuals and residual plots. Okay, yeah, I'm not gonna have you guys do residuals and residual plots. So we're gonna move on to the homework and tell you what the homework is so you can get started on that. So this is applying knowledge. So chapter 5 summary, and then chapter 5 exercises. So I'm basically going to have you just go all the way down until you see residuals. I don't think I did residuals. All right, so what I'm going to have you guys do is just 5.15 to 5.25 odd. 5.15 to 5.25 odd, and that'll be your homework. Okay? I'll post that online as well as this video.